Yeah, let's get started. First things first, let's be very thankful that it's cool in here and not as hot and stuffy as it has been in the past. Number two, if you jump into EDSB now, you'll notice that if you go into EDSB now, I have posted a link from the other group. It's a YouTube video, so you should be able to access it at any time, anywhere, okay? Just so that we are clear. So in EDSB, if you haven't seen it, this is from January 2024. It's the first video. We got through the entire first book and some of the multiple choice. Hopefully we'll finish the rest of it tomorrow. I'll put it up into EDSB for you. Our job is to take on the 2019 exam and do the same thing. Yeah, Beth. Okay, well, the good news is you'll be able to watch the video. So, okay. So sometimes it's technology. COVID was a good thing. Without COVID, we wouldn't be able to do all of this. All right. I'm going to go through the exam with you. I'll point out important pieces as we go. You don't actually have to write anything on the exam. If you just want to sit back and watch the show, you can do that. The truth is that when you're practicing, you could watch this video in the background, try the question, and then watch the video to see how it's done. It's up to you how you want to manage your time. So I'm just going to walk through the exam with you. First things first, and I guess the other group was stunned when they realized this, is number one, well, of course, you're going to get the formula sheet on the exam. You will pull it out of the exam. It's a removable page. And then they give you the terminology sheet, and I think we already talked about this already. They tell you what they want. So here's the whole one that I don't necessarily like, but the explain category. If you're not sure during the exam what it is that they want you to do, please come back to the sheet. Feel free to use it. So when they say something like this, I love the word justify, because in justify, you're allowed to use mathematical notations or computations to prove what it is that you're doing. Yes? So it's interesting. This is another way that you can actually use this with the binomial expansions. So this also sort of follows the language of what we've done. I didn't teach it to you. I just showed you my way of doing it. This is another way of doing the same thing. It's a little faster. If you want to figure it out on your own, you can. Okay. Okay, good. Moving on then, make sure too, there's been some questions in terms of how much detail do you need to provide. If it says the word sketch, you need to provide a minimum of 2 coordinate points and any key features. So make sure that we're aware of that as well. So usually like the intercepts or like the x-intercept, y-intercept's important. Maybe you have some anchor points that you want to use as well. Okay. Domain and range are only necessary if they ask you. Anytime you can put your hand up, I will gladly pause to answer your question. They're going to give you this version of the unit circle on the test. I suggest you do the following as soon as you see the unit circle. Recognize that they've given you pi by 6, they've given you pi by 4, and they've given you pi by 3. And just to remind you of those coordinates, this is root 3 over 2 and 1/2. This one is my favorite one. It's root 2 over 2 and root 2 over 2. And then the upper one, of course, will be 1/2 root 3 over 2. Okay. This is given, well, what I've written in red is not given. Okay. The blank unit circle is given. And then when we talked about it in class, we recognize that if you know the first quadrant, don't you know all the quadrants? Okay. Moving on. They have a few pages like this where no marks will be awarded for work done, so you can do whatever you want with this page. Okay, it's up to you. I suggest don't waste time on it, and let's get into the first question. You know it's a calculator question because there's a calculator, and it's right at the beginning of Booklet One. In this question, so you guys haven't seen this yet, and you can write whatever you want on your exam, but I'm just going to kind of go through it with you as quickly as I can. They're telling you that our hero, Avery, has 4 adventure books, 5 mystery books, and a comic book. It's an arrangement. So if it says an arrangement, it suggests that order matters, just not making a pile of random books. And she's placing them on a shelf. And it says, oh, this is interesting. Each type of book must be grouped together. So interesting way to kind of organize this. So each type of book must be grouped together. So this one, I think, caught a lot of people. So I want you in your brain to appreciate that this is a group of books together. This is another group of books together, and this is another group of books together. And then understanding within each group, they have their own rearrangements. Maybe a better way of thinking about this one is you have, like, you tied together all the adventure books. So really, there's just the book of adventure. You've tied together all the mystery books. So it's the book of mystery. And then there's the lone comic book. So really, you just have how many groups of books to arrange? 3. So the first part of the question is 3 factorial for just the arrangements of the groups. Then when you untie them, can you see that in terms of your adventure books, you've got 4 factorial ways of just organizing the adventure books. You also have 5 factorial ways of just arranging the mystery books. And then just for fun, you've just got 1 factorial ways for arranging just the comic book. And then you need to recognize that you have to multiply all of these arrangements together. And then because it's in the calculator section on the exam, you'll tell me it's 1,000 or 17,280. And it's okay to say ways or arrangements, whichever you prefer. That one's a bit of a challenge, recognizing that you've got, like, this is one group of books, this is another group of books, and this is another group of books. And that's why there's 3 different arrangements of just the books, the groups of books themselves. Okay. Again, this is a video. You can pause it, rewind it, fast forward it, delete it, whatever you choose. All right, question number 2. Again, it's a calculator question. And notice the marks are 4 marks. And please notice this is a whole page on the exam. So there's a belief system that they don't want to distract you with too much information on the page. So they literally put 1 question per page. How does the who feel? I'm not sure who the Lorax is.
What? Guy who speaks for the trees? The Lorax?
Oh, geez, not good. Not good. Not good. And then you can see why I shrink it for you guys. Right? That's why we could put, I'm sorry. How long do we as a division? I would think we keep them for 5 years. Yeah, we just shred them. And the truth is, like, nobody ever comes back to look at them. And there's no reason to look at them anyways, because there's no markings on them. All the marking is done on a secondary sheet. So there's no markings on your exams. I have no clue why we keep them, truthfully. All right, moving on. First things first, when I look at this question, is I notice it's worth 4 marks. The second thing I notice is the domain. The important piece about the domain is, are we working in degrees or are we working in radians? In radians. The second thing I notice about this question, it is not homogeneous. Correct. So in order for us to solve this, we're going to have to do an identic replacement. We remember that sine squared theta plus cos squared theta is better known as 1. We know that that identity is on the formula sheet that you have detached earlier on. You should see that. And then you can see there's a replacement for sine squared theta. Sine squared theta could be just rewritten as 1 minus cosine squared theta. If we make that replacement, it should read as follows. And then be careful of this minus sign here. This guy right here, he's going to might cause you some grief, because when you do the replacement, it's going to be 1 minus cosine squared theta. Now it's just an algebraic question. Can we reorganize the pieces? And I believe that's what it looks like before we attempt to solve. So it should be 6 cos squared theta minus cos theta minus 1 equal to 0. It's now simply a quadratic equation. It does factor, thank goodness. There was one a couple years back where you had to use the quadratic formula. Yeah. There was a lot of, just so you know, when we went to the training session, there was a lot of feedback from teachers like, this is hard enough. We don't necessarily need to do that. I don't know if they would do it on the next exam. They could do it. Okay, usually it factored. The quadratic formula is on the formula sheet. Yeah, sorry. It is, yeah. But just to warn you, it is a possibility. No, they didn't do it last time, but they've only honestly done it once in like 24 tries. Okay, that doesn't mean it's not going to happen. I can't promise anything. This will factor. This will factor. And then don't forget the equal 0. And I think we're pretty good that this is going to turn into cosine theta equals minus 1/3. And then on the other side, cosine theta is equal to positive 1/2. And then remember the domain is from 0 to 2 pi. And now can you see why you need a calculator for this question? Because of the 1/3. So you're going to remember that when I'm looking for theta, so on this side here where cosine theta is equal to minus 1/3, please find the reference angle first. And bearing in mind, the reference angle is based on not negative 1/3, but on positive 1/3. And if you do that, you'll discover that the reference angle is about 1.230 ... Please do not round at this stage. Okay. How do we know we're in radians? Thank you. I know what you mean. You got there. And then once we've established what the reference angle is, we go back up and the cosine value we're looking for happens to be negative. So in which quadrants is cosine negative? 2 and 3. So if you're looking for the angle that you seek in quadrant number 2, it's going to be pi minus your reference angle. So if you want your answer for this, then it would work out to be 1.911 rounded correctly. In quadrant 3, it's going to be pi plus your reference angle. So in this case here, it's going to be 4.373 rounded correctly. This is the only time we round, which is at the end. Cosine is negative in quadrants 2 and 3 because cosine is the x values, and x is negative in quadrants 2 and 3. And then they often do this, and it makes our lives easier. We actually know the answer for when on the unit circle do we get an x value of positive 1/2. So I think it's at pi by 3. And I guess the other instance must be right at the bottom, so 5 pi by 3. Are we okay with that? Why would they be negative? That's why. Okay, we've got lots of things to process. Okay. If you want on the exam, bearing in mind that you've got these poor people locked in a room in a basement marking for 2 days, you could always write it to the side here, and you can even do it maybe by size. So I think you could probably go pi by 3, comma 1.911, comma 4.373, comma 5 pi by 3. Those are the solutions. Is this necessary? No, but it might help the poor markers. And maybe you might catch a mistake too if you see it. Yeah. It's interesting that you said that. Like, if you decided to do like the calculator approximations for this, you can't be punished because you're in the calculator portion of the exam, as long as it's rounded correctly to 3 decimal places. But the truth is, it's faster if you don't have to use your calculator. Okay. So we won't mark it wrong. Next, I'm glad that now we've done binomial expansions. Again, it's a calculator question. You're supposed to find the value for m. Who's m? I don't know, but we're supposed to find m. We're looking at the 6th term in this expansion. Could we figure it out? So we need a bit of structure here in order for us to find the value. You ready? I think it's clear for us if we set this up, if we know that the expansion is to the power of 7 and we're looking for the 6th term, what's the combination that we associate with that? Perfect. So it's got to be 7, choose 5. Are we okay where that comes from? 7 because that's the exponent, and 5 because it's always one less than the term that we're working with. And it's supposed to be 7, choose 5, and I'm just kind of putting in the pieces of the puzzle and hoping it's going to work out. We know the first piece is 3x, and we know the last piece is minus m based on what we see inside the brackets. We also know that this here is to the power of 5, correct? And we know that this piece here should then be to what power? What's the first piece? What power, what exponent should it have? Should be 2. I think that helps us out a little bit. And then we actually know what all of this is supposed to be equal to. What's it supposed to be equal to? X squared y to the 5th. Okay. So we're trying to figure out what m is. I guess we could do a couple things. First things first. We know that 7 choose 5, and remember you have your calculator. So 7 choose 5 is actually 21. And then this is 3 squared, so this is going to be 9x squared. And then we got to be careful of the next piece here. It's supposed to be minus m to the power of 5. And are we okay that we maintain the negative sign there? It would be positive if it was to the 4. And apparently it's still equal to the same thing that Beth shared with us that was given in the question. If we move forward a little bit further, if we multiply these pieces together, so we got the 21, the 9, and the minus sign, could we rewrite this as minus? And if I multiply them, it's actually 189 x squared m to the 5 is now equal to the other side. I don't know if this is the way I would normally do it, but it's going to work for us, so that's good. What do you think we were going to do then? What are we trying to solve for? M. So if we're trying to solve for m, here's the m. What are we going to do at this stage then? Divide by 1. Sure, I love it. So let's divide this side by negative 189x squared. And therefore, let's divide both sides by the same value and see if anything magical happens for us. Usually, if you're doing it right, it does feel magical. They don't tend to give answers that are really awkward. So the x squareds are going to cancel, of course, on both sides. And then our m to the power of 5 is going to be equal to, it's good for us, the two negatives cancel. I kind of like that. And in fact, 6,048 divided by 189, fun fact, is in fact 32. Y to the power of 5. What do you think we're going to do next then? I'm not doing no natural log. I like natural logs a lot. Yeah, can we just take the 5th root? Yeah. So if we're just going to take the 5th root of this side and the 5th root of this side, correct? I think we're pretty good. The 5th root of m to the 5th is m. What's the 5th root of 32? 2. And then what's the 5th root of y to the 5th? Y. Congratulations, you just found m. That one's a little bit more challenging. That's the solution there. Okay. All right, next question. We've done versions of this a number of times. Is it likely to show up on the exam on Tuesday? I have no clue. Here we go. I don't know if it's, I'm gonna make it really quick then, because we just did this on the on your last test. If it's okay with you, you recognize that you're going to start off with A is equal to PERT, and there's no question mark about which formula you're going to use because they gave you the formula in the question. They're saying that you're given an initial concentration when they say, How can I make your day better? Absolutely. Thank you. Bye-bye. Bye, Bethany. It was nice knowing you. She's in trouble. I have no idea why she's getting called down. Hopefully Bethany comes back. All right, ready? So we know what the initial value is. We know 3 hours pass, and then in the future, we have this much of our concentration remaining. So as we organize this information, they try to help you out a lot. They're telling you you have to find R in the question. So you know that in the future, you're going to have 1.7505 of this substance. You began with 3.89 of this substance. E is just a base. R is unknown, but you know 3 hours passed. That's how we went from 3.89 at the beginning down to 1.75 in the future. Again, you're going to have your calculator. The first thing that you want to remember with this question is you need to divide by the 3.89. Okay? Just make it work. You're going to end up on the left with 0.45 is equal to e to the 3r. And then in this case, we are trying to solve for the exponents. And when we're trying to solve for the exponent, that's when we're going to use a logarithm. And in order to take the logarithm, we must take the logarithm of both sides. And we're going to use the natural logarithm because on one side we have e. So you're going to get the natural log of 0.5 on the left. If it's okay with you, can I use the power rule at the same time? So this is 3r natural log of e. And I'm going to remind you what is the value of the natural log of e? 1. So truly you can describe r as the natural log of 0.45, all of which is divided by 3. And make sure here that you carry as many places as you can. So we're going to state R. And it's funny too, they will accept this on the exam. If you just leave it like this, they will accept that. However, if you decide to put it into your calculator and generate a value, it's minus 0 points. And you want to carry as many digits as possible. Like I wouldn't clear it at this stage. Okay. In fact, I think if I was doing it on my own, I would probably keep it in this format when I go to the next level. Yeah, they just, the truth is, like here, they don't tell you to round it at all. And yet in the next question, and they're trying to help you out because look at the decimal places for you science people. Can you see they got like 4 decimal places going here, which is a little bit unusual. I wouldn't round it at this stage. In fact, I'm serious when I say to you, I'd probably, this is my interpretation of R. Just leave it as an irrational number, just like if it was like the square root of 2. Oh, yeah. Yeah, you can leave it as what I've written here. You can leave it like that. Well, I don't know. It makes me nervous. Like I can keep this in my calculator, right? Don't round at all. Like don't round until we get to the next part, because in the next part, if you read it, it says your answer must be correct to 4 decimal places. That's also unusual because we never usually do to 4. All right, in the question, it reads, if I get this correct, we're looking at determine the concentration of the drug 4 hours after. So we're looking for what's happening in the future. We know that the initial amount, if we're clear, was it not 3.89? E is just a number. We just found the value for R. It's up to you how you want to write it. Like honestly, I would write the value for R like this, as the natural log of 0.45 over 3. That's my R value. And we're leaving our drug for 4 hours. So that's the value here is 4. So if you zoom in, this is what I would probably type into my calculator. And I should be able to type all of this in one fell swoop. And I get an answer of rounded correctly 1.3414. And then be careful. Do we know the units? Are there units given, and what are the relevant units that are needed? Yeah, it's like units per milliliter, and you can see it. They're trying to help you out in the question. They've used this a number of times to warn you. Okay. Is that it? And how long did it take us to get through those 4 calculator questions? 20 minutes, 25 minutes? Might be. Yeah, that's it. Every other question. But so there's clear. Some people misunderstood in the other room. You always have booklet 1. I never take booklet 1 from you. But at 45 minutes, you put your calculator down, and then I give you booklet 2. And then when you finish the exam, you hand in both booklets. You want me to say that one more time? You have booklet 1 the entire exam. I never take it from you. At 45 minutes, you put your calculator on the floor. I give you booklet 2. At the end of the exam, when you submit your exam, you hand in both booklets. Yeah. Usually it's right above LN, because they're inverses of each other.
Oh, like.
Yeah, so then if you want to do here, you're trying to do like the 3.89, right? And then you're going to go second function, the natural log button. Does that help?
Oh,
And it automatically makes an exponent. Okay. Next, we're supposed to describe what her error is. Sure. And again, like this video is recorded, you can come back and replay it as you need to. Okay. You don't necessarily have to write all this stuff down. It's all in the video. Okay, okay, next up. This is very common. You're asked, or Arian's asked, to find the arc length. So the arc length is always S. Theta is always the angle. The trouble is our hero, Arian, put 20 degrees in. Are you allowed to use 20 degrees with this formula? No. Theta has to be in radians. So you're supposed to describe her error. Really, what are you going to say? She used degrees when the angle should be in radians. And then I don't think it asks you to find the correct answer. It just asks you, what did she do wrong? So just tell what they did wrong. Okay. So you can write it anyways, but you know, make sure they can read your handwriting. I don't know what to do with that. Like, make it neat. Make sure your X's look like X's. Okay. That's what some people might be practicing on the weekends. Okay. Sorry? Yeah, I'll come take a look at it later, okay? Next. This is interesting. This question is worth 1 mark. This question's asking, using or looking at the graphs below. So 2x plus 3 is the linear function. 2 square roots of minus x minus 1, that's this function here. Do we know where the solution is? Because they're asking you, when are these 2 functions the same? The better question is, when do they share the same space? At what moment are they in the same location? When x is equal to minus 1. Done. Next question. That's it. Remember, it's based on the x value only. I don't care about the y value. You get half a mark off. Don't do it. Look at the question. If we go back to the question quickly, do you see y in the question? So don't give me a value we're not asking you for. I don't care about the y value. I know that sounds harsh. That's a whole page of the exam right there. That's lovely.
Okay.
That's lovely. Next, 3 marks. Again, make sure you check the marks before you start the question. That's always a good strategy. This one's really nice. Just solve algebraically. There's a couple of ways you could choose to do this. I think for me, the easiest is just to put both logs on one side. I think the reason why I like this is this becomes a negative log is now a positive log. Notice that the bases are the same. I think the bases are always going to be the same. All right, I think we appreciate now that if you have two logarithms of the same base being added together, and the logarithm rules are on your formula sheet, correct? If you double check, they're there. And if this is the case, if you have two logs that are added together, it can turn into one log where the arguments themselves are multiplying, and all of which is equal to 5. And then in order for us to solve for x's that are trapped inside of the argument, I think it's pretty clear, or at least I hope it's pretty clear, that we're going to have to change to exponential form. The base is 2, the exponent is 5, and it's equal to x plus 3 times x minus 1. And again, how many times have we seen this? We've taken a question, it's a logarithmic question or a logarithmic equation, and now it's turned into a quadratic equation. Funny enough, you still probably have access to your calculator at this stage because you're probably still within the 45-minute window. But what is 2 to the power of 5? 32. But I know during an exam, we like to double check. I understand that. And then when we FOIL this, it should turn into x squared. Make sure you FOIL this properly. It's going to be x squared plus 2x minus 3. Set it equal to 0. Pray that it factors. So it's x squared plus 2x. I guess is that minus 35? I bet it is. And then when you solve this, you're going to tell me 0 equals, I guess it's x plus 7 multiplied by x minus 5. Okay. And then you're going to notice that there's two options here. It's not unusual for us to have two options with this type of question. And the truth is, though, one of these options probably doesn't work. Where do we go or what do we do to verify? Yeah, put it to the original. And do you have to show a ton of work to tell me whether it works or doesn't work? But right away, can you see that minus 7 is definitely not going to work? Now, double check. Sometimes they both don't work. But if you look at it, I'm pretty sure 5 works. Okay. Right. Are we good? That's number 7. Next, here's number 8. I don't know. I think I actually got stuck with marking this question. And after a while, I just wanted to bang my head against the wall. It says explain, so you're not allowed to use math notation to explain. And you're supposed to explain to me why the value of n has to be greater than r. Looking at this formula, why must n be greater than r? No, so you're using the definition of the formula to support your argument? No. I'm not disagreeing with it, but that's not what they're searching for. They are, and I'm marking them, so I'm an agent of theirs, therefore I'm against you, I'm sorry. But remember that when we're doing these combinations, don't we just suitably have like a larger group and a smaller group? So how could we frame our solution or our explanation in words? You can't have 0 groups, this is true. Well, I don't know, like, can we do this? Because I just want this to happen because it's going to make me laugh the entire time that I'm marking, because people are going to go, you guys are going to start with, I feel like. I could just see that someone say, I don't know who taught this, but every single explain question, their students say, I feel like, and then I'll just smile quietly to myself. Okay. I feel like n is what? The total number of objects? And aren't they like subgroups? Or R is the size of subgroup? You don't like it? Well, no, because like if I did like, and this is because I like it when students say like if you do like 6 choose 2, you have 6 objects to choose from, and aren't you making smaller groups of 2? Okay. So here, n is supposed to be the total number of objects that you can choose from, and r is the size of group you're selecting. So r is the size of group being selected. Do your best, write 2 paragraphs, drive the person who's marking this crazy. You'll probably get the 1 mark. Is it 1 mark? Yeah. Has to be smaller. And then you could say, therefore, R has to be less than N. Don't put an exclamation mark because we'll think it's some factorial. Yeah. Yeah, you can't take more than what you have. Okay. No overdraft available. No, no math computation, no math anything. Agreed. Yeah, what will happen is if you do this, like if you put this down, I love this. I think this is what we should be all over. They will disregard it. They'll only look at the words that you use. But you can put down, I feel like. All right, let's keep our personal opinions not in the exam. Don't do it. All right, next. A bit more question. We're taking a function that we should recognize the absolute value of x. We're applying the following transformations to create g of x. Can we do it? Now, we got to be careful. They tell us that y is equal to the absolute value of x. So you're going to apply the transformations directly. So when you answer this question, excuse me, g of x equals, and they did this nicely too. They gave it in the order that it happens. You're supposed to do a reflection in the x-axis. Remember, this is the x-axis. So if you're doing a reflection in the x-axis, can you see it's a change to your y values? So you're going to have to go minus the absolute value. That's how you're going to get the reflection in the x-axis, by having a minus sign out front. Then you have a vertical translation 5 units down. Okay, I lied, because we're going to do that. Oh, and we got a horizontal stretch by a factor of 3. Careful then, if we're going to have a horizontal stretch by a factor of 3, we're going to have to write this as x over 3 inside and the bracket, and then shift it 5 units down. Okay. I lied to you. I thought they gave it to you in order. They didn't. Usually they do, so that was unfriendly. You can write it over as 1/3 x. That's fine. Did they tell you specifically the function? So then answer in terms of the absolute value. So it happened too where students did do it. Like they wrote the following. They said, oh, g of x is equal to minus f of 1/3 x, like this, minus 5. And they lost a mark because the function is clearly defined as the absolute value of x. Okay. No, I know, no. We agreed to this format, but I know what you're talking about. We will do it this way. Are you okay? Okay. All right. Let's go to the next page. Explain why the graph of y has a horizontal. Oh, look, it's my favorite word. So how do we explain why? It's okay. So do we agree? Like, I agree. I like bottom heavy. And I know they've marked in the past and they know it's one of my students when they say it's a bottom heavy function. Well, I think it is, but what does bottom heavy mean? It's just, what does that mean? Perfect. So like, I don't mind if you write bottom heavy, but you have to explain what does bottom heavy mean? Because you're assuming the marker knows. Well, they didn't take math with me necessarily, right? So bottom heavy just means we, like, the math person wants to say that the bottom is increasing at a significantly faster rate than the top. Therefore, it approaches zero. But we don't need to make it that complicated. What do we need to just say? And that's why bottom heavy makes way more sense. It's like really straightforward. How are we going to explain it? So I feel like let's just keep it really tight. The degree of the denominator is greater than the numerator. Therefore, this function has a horizontal asymptote at zero. I don't care about any coefficients. Okay, sorry. Like what we're recognizing is this is degree 1 and this is degree 2. So the top is degree 1, the bottom is degree 2. We call that bottom heavy. But we say, I feel like the denominator, so denominator is downstairs, the deminator, but the denominator is downstairs, has a greater degree. They like that word. And degree is just a leading exponent. The greater degree. You're welcome. Therefore, horizontal asymptote. I don't want to write anything, but horizontal asymptote at zero. That could be a symbol. I'm not sure. Okay. Again, write 3 paragraphs, drive somebody crazy, move on. Draw pictures of cats if you need to. Okay. Next. So we just learned how to do this. This is a fun one. I actually kind of like this one. You're given the 2 functions f of x and g of x. So here's f of x, and then below, of course, it looks like that's what g of x. You're supposed to evaluate g of f of 2. So what I want you to do is recognize you need to figure out what on earth is f of 2 first. So what is f of 2? What that means is you're putting 2, your x value is 2. So we're going to travel over here to where 2 lives. This is where 2 lives. And notice you get a coordinate from the function. And the coordinate is if you put 2 in, what comes out? 4. So I'm going to tell you that f of 2 is, well, that's 4. Then you're going to go back to this composition because the composition is asking you for g of f of 2. And we just figured out that f of 2 just happens to be 4. So what's g of 4? Well, we're going to go to where time is 4. So we're going to go to where 4 is. And we're going to go down to the function known as g. And we get another coordinate. If you put 4 into g, what does g return? Negative 2. So your final answer then is simply minus 2. 1 mark. Okay. Again, use the functions, understanding that when I'm asking you for the function value, I'm simply asking you for the y value at that moment. And the moment, of course, is x. Next. Poor Kennedy. Kennedy was asked to solve the following question over all real numbers. Kennedy suggested the answers was pi by 4 and 5 pi by 4. And to be fair, Kennedy wasn't completely wrong. What did Kennedy fail to do? Yeah, so the domain is unrestricted, right? So describe her error. How describe, I think it's funny. So now you've asked me a good question. I always get confused too. So I have to go all the way back. What does describe allow me to do? So you're on the test, you're like, explain, describe, are they the same? I think describe says use words to provide the process or report details of the response. Well, I don't know what that means, but use words to provide the process. I think there's more latitude here. You can be more mathematical in your response. Okay. I think we understand that she's given two solutions only in terms of one rotation on the unit circle. So what does Kennedy need to do to fix her mistake? I like that. She's provide the general solution. So how are we going to best go about that? You could. How about this? Let's be harsh. She failed to consider what? The domain. I like that. That's clear. You can leave it like that. Put an exclamation mark for emphasis. Because the domain, I feel like adding in, like I want to write more because the domain is all real numbers. It doesn't ask you to fix her mistake. Yay. But that's what I would do. Like in my brain, I'm going, oh, blah, 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 where n is an element of the integers, 2 pi n, take it from there. Z, it's still Z. Ready? So you can anticipate this. I think I've warned you, they like this type of question. Again, it's 3 marks. You probably, at this stage, you're probably about ready to lose your calculator in terms of timelines. All right, they're asking you to solve algebraically. I think that's the version of question that we're most comfortable with. You are given both of these formulas prior to or on the formula sheet. So we just started off with n factorial over n minus 3 factorial, 3 factorial. That's the left-hand side. On the right-hand side, it's going to be 3. This one is n factorial over n minus 2 factorial. That's the way it looks at the beginning. Okay. There is a lot of screaming in this question, right? So you are supposed to find creative ways to get rid of the factorials. So I think we can see there's a relationship here that we can take advantage of, and there's a relationship here that we can take advantage of, okay? So on the left, you're going to break this down into n times n minus 1 times, I don't like this, n minus 2 times n minus 3 factorial. That's the top of the first, sorry, that's the top of the first fraction. All over n minus 3 factorial. And is it okay? Can I just write 3 factorial is 6, just so I don't have to put the exclamation mark there? Equals 3 times. On the right-hand side, I think this one's okay. It's going to be n times n minus 1 times n minus 2 factorial all over n minus 2 factorial like this. Let's cancel out the factorial notations where we can. And if we clean it up a little bit, are we okay to there? All right, so if we move forward from this, I'm just going to reorganize it just so it's clear to see what pieces that we have to work with. And I'm a bit nervous because I don't like the fact that there's 3 n's on this right hand or on this left hand side. And then on the other side, we got 3n times n minus 1 like this on the right hand side. So moving forward, what could we do from here? Can we put it over 1? Do we want to do that? We haven't done anything wrong. I'm just trying to do my best here. Is there something I can do to make my life easier moving forward? Yeah, is it okay for us to recognize that if we divide both sides by n minus 1, so it's a little bit more creative, the algebra, because the thing is, I don't want to do this expansion. No, because I don't want to create an n cubed. We don't solve n cubes. But if you listen, it's okay for us. Like, you know how we multiply both sides by a value? We're also allowed to divide both sides by the same value. So if I came along here, and well, how about this? I multiply this side by 1 over n minus 1, and I multiply this side by 1 over n minus 1. Why is that useful? Yeah, you can cancel this n minus 1 with this n minus 1. And it's all because it's the equal sign, because the equal sign says whatever you do to one side, you can do the exact same thing to the other side. Can you see we get rid of that n minus 1 there? It's even better. Yeah, that's even better. So if I keep moving forward, like I can get there now, but if I keep moving forward, we end up with n times n minus 2 all over 6 is equal to just 3n. I think we've created something that we're comfortable with. This is going to be, hold on, n squared minus 2n is equal to 18n. And I wish I had listened to Dorsa, but I got n squared minus 2n is equal to 18n. How would we solve this? Maybe this isn't the worst. What would we do to solve this? Well, what do we normally do when we're trying to solve a quadratic equation? So this one is actually going to turn into n squared minus 20n is equal to 0. And then where do we go from here? So it's not bad that we've seen this. What do we normally do at this stage? Just factor out n. And now you're left with n times n minus 20 is equal to 0. Then your options are 0 or 20. Which one of the options is actually valid? 20. Because when we go back, you can't have the total number of objects is 0, but 20 could be the total number of objects. So in terms of degree of difficulty, this exam feels more challenging than the 2024 exam. Okay, good. Moving on. Love it. So when they give you this question here, you notice how they give you two graphs? They really want you to use the second graph. And this is just, we did this, you're supposed to take the square root of the function. So I'm going to do it on the top one just so we can see it better on the screen, but, oh, lost it. That's not good. Hold on. See how fast I can scroll. It's pretty good. Here we go. They're asking you just draw the square root of the function. I'm going to remind you. The square root of 0, it's where the y value is 0. And the square root of 1, where the y value is 1, are they not the same? Those are your invariant points. Then they're just like me. Can you see that they went all the way up to 4 in terms of the y value? You can see this is where the original function is equal to 4. And the reason they gave you that, because what's the square root of 4? 2. Then you're going to remember that you're never going to take the square root for anything where the y value is negative. And I know you guys like this stuff. Don't forget the blue zone, right? What happens in the blue zone when you're taking square root? You get the bump. I like that. And now be careful when you draw in the bump, right? When you draw in the bump, that it's still a function. Don't go crazy with the bump. And if there's an arrowhead, there better be an arrowhead on yours as well. Just going to remind you of the blue zone, right? It has to be above. Between 0 and 1, when you take the square root of a value between 0 and 1 in the blue zone, it's greater than the original function. I'll remind you of that. If I said to you, hey, you know what? I got 1/4. If you take 1/4 and you take its square root, isn't it square root 1/2? So the truth is, when you take the square root of a value between 0 and 1, you actually make a larger value. Fun fact. 1 mark or 2 marks for that. Nice. Next page. Honestly, no, but they'd rather you did it on the bottom. Like it happens so often, we don't mind. Okay, so here's your identity. I think I said to you the same thing over and over again with the identities. What should you do first? How do you get the cheap mark? It's still true. Hasn't changed. Yes, if you want, let's start right there. Let's, no matter what happens, we're just going to put QED at the bottom. We're good. Okay. Now, what it will look like, we're not sure, but we know how it ends. What can we do? Okay. So we're going to recognize that we're going to turn everybody into sines and cosines because you will get a mark for that no matter how you proceed after that. Okay. So when we take a look at here, we got secant theta. I'm going to remind you that secant theta is 1 over somebody. And in a perfect world, it would be 1 over sine, but it's not a perfect world. So it's 1 over cosine theta minus. Can we rewrite tan theta in terms of sine and cosine? So isn't that going to be sine theta over cosine theta and multiplied by, and I'd write it as sine theta over 1 just so all the pieces fit together nicely, okay? Divided by, and then downstairs in the denominator, you're going to rewrite this as sine theta over cosine theta multiplied by sine theta. And for now, I'm just going to put that over 1. That may change in the near future. And the reality is I just want to divide, but I can't divide my fractions unless I have a single fraction upstairs and a single fraction downstairs. So what that means is we need to create some sort of, oh, it does have a common denominator. I don't have to create anything, do I? Usually we do, though, right? We multiply by convenient versions of 1 to make a common denominator. So if I work forward with this, can I not rewrite the top as 1 minus, and then look, isn't this nice? We got sine theta times sine theta. What's that? Sine squared theta all over the shared denominator cosine theta. And then all over, and then downstairs, we got sine squared theta all over cosine theta. Then what do we usually do now that we have a single fraction in the numerator and a single fraction in the denominator? Multiply by the reciprocal and then hope stuff cancels. And usually it does. So the top fraction stays the same. And then we're going to multiply by the reciprocal of the bottom. And I'm feeling pretty happy now because it seems to me the cosine thetas are gone. And then when we restructure this, this one's a little awkward at the end, but when we rewrite this, is it not like 1 minus sine squared theta all divided by sine squared theta? And then they unmerge. Okay. Usually I ask you to merge fractions together. We're going to unmerge. Yeah. Does that help us? Okay. You can, but remember our destination has 2 things that are separate. And right now, if I unmerge, could I rewrite this as 1 over sine squared theta minus sine squared theta over sine squared theta? So you can see we unmerged. What is 1 over sine squared theta better known as? Cosecant squared theta minus 1. You can, but not right now. I agree there's more than one way. Which then you can turn nice. I like it. I like it. I like it. Good. That's a pretty good one. I think this is, it's interesting. I think this exam is significantly more challenging than the 2024. Is it? Oh, trying to make it easy both semesters? They're not going to try and correct their mistakes? They have no conscience. Okay, here we go. 1 mark. Where is minus pi by 12? A little under the thing. I'm good with that. And this is funny because I lost a mark on this. I think we talked about this. This is the this is the angle when you draw this, what am I missing? Because right now I am losing something. Yeah, the direction of the rotation. Are we clear? So this is where theta equals minus pi by 12. Good. One of those moments like, oh, this is too easy, and then we lose marks for no reason. There's 16, 17. Hey, we just did this. And they regretted this one a lot. Well, they were hoping that people would factor this, right? They were hoping it's 2x squared minus 7x minus 15. And when you factor this, it's got to be 2x, this is going to be x. This is probably going to be, hold on. Yeah, this is going to be, thank you. This is 5, this is 3, this is minus 5, this is plus 3. Now, they're telling you you're supposed to create h of x by multiplying the two functions together. So they were hoping people would write 2x plus 3 here and x minus 5 here, and that would be correct. But, and a lot of people did this, and it made me laugh. They said that f of x was equal to 1, and g of x was equal to 2x squared minus 7x minus 15. Yes. Oh, I enjoyed marking that. Yeah. It just says it has to be a product. But and is this a function? Is f of x equal to 1 a function? Yes. They were hoping people, so you could do either. Is your answer wrong? We don't mark correct answers wrong. This one, as math people, we liked it. Then that's different. But they didn't give you that option. Hey, look, it's the fun page. All right. It's just they have to put, like, you could use it for scrap work, you could do it for whatever. But the trouble is, like, they're okay. We're gonna jump into the start of booklet number 2.
Good afternoon. Leaving already before the bell, I have an important announcement to make, and that is with regard to our student council election. First of all, I want to thank all 3 teams for their effort and their courage, and to again run on a platform. And it is my pleasure. The students of Shaftesbury have spoken, and they have spoken decisively. And our student council next year for 2024-25 will be Team B. Definitely Team Rebecca is, and Micah Lesser, congratulations. We'll make another announcement tomorrow at the student council barbecue. Thank you, everybody, and sorry for the.
All right, so we're gonna stop there. Okay. We're gonna stop there. We'll try and finish the second half of the exam tomorrow. Bearing in mind the 2024 exam is already available, the first part anyways. Okay. Make sure you are reviewing. At this stage, I would tell you, focus on the 4, now 5 exams that you have. All right, take care of yourselves. See you tomorrow.